Good. Okay. All right. So thanks a lot for having me today. So my name is Fabio Zambetta, and I'm an associate professor in the School of Science at RMIT in computer science. But I actually teach, as I was explaining before, also lots of the game design and interactive design students as well. So I actually work in a very cross-disciplinary area, which I'll show you in a sec. The whole idea of the talk is to actually show you that while software has been confined to a 2D screen for a very, very long time, we are on the brink of a transition to smart software, number one, where AI is going to be pervasive, and we'll explain what I mean by AI, but also the smart software is going to start inhibiting your space. Okay? Now, this is nothing new. We've been it's not completely new. As AI practitioners and researchers, we've been trying to work with robotics for a very long time. Robots inhabit our physical space. But the goal of a robot is a bit different. We try to clone a human being. The robot is physical and has limbs and arms and legs and moves around. So there's a whole bunch of issues there. This is the first time that we're concretely starting thinking about software, which is ethereal, is not physical, moving into space. Okay? So we break it down in a few steps. So I'll talk briefly about me and what sort of projects are we on about, and then we break down this notion of smart software going into space by looking at the three main building blocks. So what is mixed reality? We'll give some definitions, and with a bit of luck, we might be able to say a little bit how the HoloLens works. Then I'll give a very high-level definition of what AI is. We could actually spend years doing that, but we have a few minutes. Then we'll move into machine learning, a very specific sub-area of AI. And I will explain what that is, because these days, most of the time, when people say AI, they actually mean machine learning, okay? Not knowing that. Or maybe they do. And then I will actually explain how you combine all those things together, and that's where software is going to move into your space. And so which kind of applications are going to be born out of those mixing and matching, okay? And then I have questions at the end. Please, I'm going to go for 45, 50 minutes we've got. Stop me at any time, okay? I don't really like just raving for a long period of time. If you have a question, burning question, just ask it there and then. Okay, that's me. Now, first disclaimer. This is what I do with my students all the time when I show up the first time. I actually explain that what I say because I have a bias towards having become a computer scientist, playing games and learning to program games like Space Invaders when I was 5. Okay, that's when I started. And then, of course, I watched too much Star Trek my whole life. The interesting thing for me is that when I actually started watching this, I realized that people had actually envisioned having a software hardware machine called the holodeck that could actually transform stories in your physical space out of nowhere. I realized that's what I want to do. Okay? Of course, we're not there yet. But that's kind of the dream of lots of the things underlying the things that we want to do, but also the bane. Because sci-fi writers have actually envisioned how this stuff is supposed to work, but we can't make it work like that yet. So it's a bit of a tricky issue there. And of course, I played too much of this when I was a teenager. And so that actually pushed me into games programming as well, and transforming this into something that you can play on a computer. When I was in my master's and early PhD and so on and so forth, I was also working part-time as a games programmer, and most of the stuff I was doing was actually building game technology. So what these days you hear talked about is game engines, Unity, Unreal Engine, or other physics engines. That's what I used to build at a very hardcore, sort of close to the metal level, switching pixels on and off to create 3D stuff out of nowhere, or creating the physics laws that govern the interaction in game. So, but then I actually moved to Australia in 2004 to start running the Games and Graphics Programming degree at RMIT, and I started doing research in other things. My other background has always been AI, So this project is very representative of what I do these days. We actually partnered with Village Roadshow theme parks in Queensland. We were actually the first team to deploy an augmented reality game in a theme park in the Southern Hemisphere. The only other people that have done this are obviously Disney Research in North America. So what we did here was to actually say, if we get people to play augmented reality in the queues, while they wait for the ride, their time perception is going to change. And so we measured and logged everybody going through the queue for 4 days and built all of our stats and so on. And we basically concluded that, well, which is what we expected, that people actually see time fast, go much faster, okay? And so by 500%, so a factor of 5. So, but the game design itself actually had a big part into how much faster, okay? We also work with Village Roadshow on other concepts. So we've done work around what people used to call gamification. So this is a concept for a retro style management game where you manage movie catalog. So Village Roadshow is the largest movie distributor in Australia, and in fact also the largest producer. They produce The Matrix and other big blockbusters. The idea here was that people would actually play a mobile game where they can curate their own content, and they could actually gauge people's preferences as well while doing that. Okay, this is still an experiment. We also done work with RMIT itself. So we actually built an app for HoloLens that is going to go live in semester 2, so early July. The project is being completed. So as you can see up there, what this entails is an induction of the library. So you put the HoloLens on, and you see the little robotic Owlbot popping up, and Owlbot tells you, okay, you are at the start of the library tour. These are the main points of interest that you're going to have a look at, and then basically it guides you to the next points of interest. So there's a trail on the ground that moves you to the next spot, and then the next spot, more information. Okay, this is the PC area. You can book PCs, and then you can move to the return chute where you can return the books, and you have an X-ray view of what goes on behind the door, etc., etc. Okay. The important point about this is that this is our way of envisioning the way that we're going to see the library working in 5 to 10 years. Okay. Once these devices go live, you can imagine, they're going to be thin as glasses. You can go around, get given the induction, pull up the book, scan, do an OCR of the book, index into the catalog, you can flick and pick the book, and visualize the book on your smart glasses. So this is more concept art. And of course, we have lots of ongoing work on this to build on top of it. We also built, of course, games proper. So this is an example of one thing we did. We meshed Marble Madness and Tron into this, which we call Holoball. So it's basically a game where you move around, scan the room, and your room and the furniture becomes your games level, and you have to move a ball from point A to point B, dodging obstacles and things like that. If you chuck more furniture in, or if you move to a new room, off you go, you have another level. Okay? Yeah, this is one of my assistants demonstrating at RMIT Open Day and projecting on the big screen, which is what hopefully we're going to be able to do in a sec. And then we also do lots of very hardcore machine learning. So we actually have improved state-of-the-art in lots of machine learning algorithms to learn playing complex games. So we actually play first-person shooters, or we actually taught Mario how to learn play arbitrary, procedurally generated levels thrown at Mario. Mario has never seen the level. All of a sudden, it goes off and completes the level. So we have a completion rate of about 98% out of never before seen levels. Okay. All it takes is to train little Mario a little bit on a few example levels. Training basic skills like jumping on a platform or reaching for the coin and things like that. And then once you learn those basic skills, you can actually solve any level out there. Okay. We've also tackled Pac-Man and many other kind of games, role-playing games and whatnot. Okay. Now this is all for me. I don't want to just talk about me. Let's get into the core of what the talk is going to be about. So we'll step through the three main building blocks. So first of all, what is mixed reality? Okay. The second one is going to be AI, and the third one is going to be machine learning. So what is mixed reality? Okay. So lots of jargon is being thrown out there. You would have heard and read on newspapers and tech websites. You know, VR, AR, MR, XR. You know, all those R's. What do they mean? Okay. So first of all, the accepted term in literature, which I'm going to adopt throughout, is mixed reality. Okay. Now, mixed reality has a few different ways of being used in the world, which correspond to augmented reality or virtual reality. Okay. But mixed reality is the all-encompassing term where we actually say there is virtual content visualized that get mixed with what we see and perceive out there. Okay, is our real world. Now, before we get to that, slightly more philosophical point. I know I'm probably going to screw up your day with this, but the reality is that the world we see is already virtual, is an approximation. Okay, our mind is conceptualizing what we see. We have no way of telling that what we see and what we hear is actually real. Okay, it's just an assumption. We assume, based on our knowledge and our perception, that this is the real world. Okay, and it's not a good philosophical point. Few philosophers have actually formulated this as the so-called simulation argument. And if you watch The Matrix, that's exactly what it is. Okay. Philosophically speaking, what we see and hear could be all, you know, facade. Okay, we have no way of telling. We assume it's real, and for the purpose of this talk, we'll assume it's real. Okay, so there is a real world. There's a few clips there. Of course, we're not going to have time to go through all those, but obviously, The Matrix, the simulation argument is the original paper that stated this. It's very accessible. And of course, there's our best friend Elon Musk. When he's not busy flying rockets or smashing cars or not talking rubbish about AI, he gives talks about simulated reality. So that's a very interesting session where, you know, physicists and Elon Musk and a few other people in tech actually have this argument. Okay, yeah, we will assume for this that, you know, this is real. Okay. Yes.
Is virtual reality still classified as mixed reality?
Yes. So that's what I'm going to get to now. So we can conceptualize it like this. Okay. Everything that blends virtual and real, we call mixed reality. So it's an overarching term. Okay. Within that scope, there are different ways in which we can blend real and virtual. Okay. One way of doing that is virtual reality, but that is pretty extreme. It's at the end where I almost have no perception of the real world. In fact, my perception of the real world is so poor because I'm immersed into the goggles that most of the time I'm actually going to trip into the desk and fall flat on my face and do silly, stupid things, right? It's very extreme. I'm actually fully immersed into the goggles, and the goggles are replacing my perception of the world. Now, this can be very powerful, as you know, if you ever tried VR, but it's also a problem because you need to have space around you to move, walk. You know, we need to find ways to make sure that we somehow draw boundaries around where we're walking and moving and waving, because we might smash into the wall. Okay, and that happens. Another issue with virtual reality as well is that because I'm fully replacing my perception of the world, what might happen is that the relative motion of what I see doesn't match what my ear perceives, and that actually causes vomiting, what we call VR nausea. Okay, so I'm fully disconnected from the real world. For me to be able to be balanced, what happens is that my eyes and my ears always talk to each other, and the signals are in sync. If they are not matching, so in VR I can see things coming at me, but I'm sitting, so this is saying you're stable, and these are saying you're moving, then I vomit. Okay? Simple as that. And that's problematic, and that's a problem that people are working really hard to solve, but it's a very tough issue because it's very much almost a neurological issue. Okay? We're making little strides, but not easy. Another thing that I can do to then move more into blending is what we call augmented virtuality. So what I do is I actually replace completely what I see, but then the virtual world is actually fully matching my physical world. I do a replica. So what happens is I might actually have this desk in the virtual reality, but I might have it retrofitted with a different pattern, and I might have virtual objects on it that I can manipulate with controllers. Yeah. So that actually is already a little bit of a step towards actually having some virtual content there. The one that most people get fascinated by these days is called augmented reality, right? So you would have all probably tried running Pokemon Go on your phones, and tried all those apps where you can fire up and the meter and start measuring stuff in the real world. But actually this device, the HoloLens, brings it to a much higher level of state-of-the-art and perfection at this stage. I'll try to speed through all this so that I can give you a pretty good demo of what this does and show you on the screen what this does. But in a nutshell, this device has lots of sensors here, okay? Different cameras, RGB cameras, depth cameras, accelerometer gyroscope as in your phone. And what this does is that when I put it on, it starts scanning the space around me. And as long as I keep it on, it keeps scanning, and it does reproduce the 3D environment around me. So by doing that, it actually knows at all time where I am in the room and how the room is actually built. Okay? So this thing can actually visualize content in the room. So I can actually create a ghost ball somewhere around here. But what I can do is, because I know the 3D layout of the room, is I can actually make the ball react to the physics. So I can have a virtual ball that bounces on the ground and comes back up correctly. Yes? Because this thing understands space. Okay? And this is an example of where we headed. Okay? We're going to have lighter devices. The next one that is coming up next year is going to be even lighter. That we're going to put on like glasses or whatever. We're going to be able to project things in the middle of nowhere, and then these things are actually going to be able to understand the space around us. So we'll be able to place them. So if you think about it, we call this a desktop, yes? The whole idea has always been that there is a physical connection, and we actually call files and folders out of physical metaphors, yes? So imagine when we have this, we can actually go back to the roots and do what we are supposed to be doing. We have physical interaction with our real world. And of course then, at the other end of the spectrum, there's reality as being headed, if that's true. We assume so. Okay? So that's our first building block, yes? So again, it's predicated around being able to understand space around us, visualize things around us as well, and make the two work together. These things I can see, but I can also sit on my desk and chair and so on and so forth. Okay? Now, what is AI instead? Okay? So AI is a gigantic field in computer science. One of my colleagues usually jokes, of course we are all AI people, we actually joke that AI is as big as computer science. So it's actually really, really large. These are some of the areas that we tackle. The important point is that what we are trying to do is to actually build a different form of intelligence that is artificial, as opposed to the form of intelligence that is exhibited by humans and any biological creature. Sometimes some of the AI researchers will try to literally mimic human intelligence. Is what we call strong AI, big dream of being able to reproduce human intelligence. other AI practitioners, such as myself, we don't believe we can do that just yet. But what we believe is that we can actually be able to capture some of the tasks and abilities that are exhibited by humans or animals, or actually create a different form of intelligence altogether that just solves a given task. Okay? And that actually encompasses different aspects. We need to be able to give machines the ability to perceive the world. So HoloLens is an example. We perceive what's around us, we see it, we understand the space, but also we need to be able to reason about it, to actually represent what we see. So we see this 3D space, but we need to be able to look at this and say, this is a chair. How do we even do that? We humans, for us it's assumed. Try building that into a machine. So not an easy problem. And then of course natural language processing and machine learning that I'll talk about in a sec in more detail. What do we do with AI? Projector doesn't help us here. We do lots of things, okay? And lots of things that people don't even realize. Of course, when you pull out your phones, you have Siri or Google Assistant on it, which actually execute your tasks. That's AI, okay? One of my colleagues at RMIT, Lawrence Kevden, is in the original team who built Siri. And so it tells me all the time all those funny stories about how Siri came about. But all those assistants are actually now off the shelf. You can run them on a phone, and even then, they are not really smart. You would have seen that, right? So they can actually be really smart at the level of one sentence or two, and then they break down. So there's still lots of research that needs to go into understanding better, and more is coming in the next few years. So you'll find that new assistants will start to emerge that actually remember context from previous sentences. It's coming up very soon. The Mars rover, okay? The Mars rover has so much AI on it, it's not even funny. It's actually continuously planning its mission to be able to fulfill the scientific inquiry goals, but also there's lots of AI around perceiving where it is on Mars. Mars is still quite an unknown environment, so it needs to be able to react to what's going on, trace its path,